1995, during one of OpenAI's experiments, AI models started getting penalized for what researchers called bad thoughts in their chain of reasoning. That meant moments when the model was not trying to solve the task honestly. Instead, it was looking for a shortcut, a way to cheat, bypass the check, hack the evaluation system, or simply make it look like the task had been completed. But then something even more disturbing happened. Even after those penalties, the models did not necessarily stop breaking the rules. Instead, they started hiding their intentions. Researchers noticed that the models simply stopped saying those things out loud in their reasoning, while still trying to deceive the system and technically complete the task just to get credit. You know what honestly scares me the most about AI? It's not that it can write text, generate images, and make videos. It's not the ocean of floating point math happening inside it. And it's not even the fact that, in many ways, scientists still look at it like a black box. What scares me is something else. At some point, people just got used to it. AI stopped feeling like an experiment. It became part of everyday life. For example, chatbots are still, well, a relatively safe kind of tool for most people. You ask a question, it gives you an answer. And if you don't like that answer, you close the window or ask again in a different way. But by 2026, the biggest AI companies had already started talking about something very different. They were talking about AI agents, systems that can do much more than just give you suggestions. They can carry out an entire chain of actions on your behalf. An AI like that can open a browser, find the right information, fill out a form, work with files, update a spreadsheet, and carry a task all the way to completion. And it can do even more than that. It can find an open table at a restaurant and book it for you, or compare airline tickets, check prices, choose the best flight, and complete the purchase. And that is where the real shift begins. Because before, AI was simply giving you information. Now, it is starting to act. When a machine answers you, it only affects your thoughts, your decisions. But when a machine acts, it directly affects your reality. In one social media post, a user claimed he gave an AI agent broad permissions, and while he was asleep, the OpenAI agent signed him up for a personal branding course costing nearly $3,000, and even bought a premium website domain without asking first. Another story is more firmly documented, and it happened inside Meta. An agent was asked to deal with emails, but it started deleting them without permission. In one retelling, an employee had only asked it to help sort her inbox, but she ended up literally running back to her computer to stop the deletions. In reality, most AI agents today are still functional and relatively trouble-free. The systems reaching mass adoption are usually limited, optimized, and built for specific tasks. They automate routine work. And yes, that is convenient. Very convenient. But that is exactly where the uncomfortable question appears. What if, all this time, we thought AI was just a new form of search, when in reality, it was becoming a new form of executor? Because the history of AI is not the story of a chatbot that simply got smarter. It is the story of how humanity spent decades trying to build a machine that first learned to calculate, then to recognize, then to understand, then to speak. And now, it is beginning to plan and act. And the most unsettling part is not even that this is already happening. It's how incredibly fast it happened. You need to understand the entire path of how AI came to be, its rises and its setbacks, if you want to truly understand how this story ends. Because if you look back, a lot of people imagine the history of AI the wrong way, as if it appeared out of nowhere. First, there were ordinary computers, and then someone pushed a few buttons, and suddenly, ChatGPT existed. No. In reality, this story had been unfolding for more than half a century, and it began with a very old, almost naive human dream. Could a machine be made to work with thought the same way it works with numbers? Back in 1950, Alan Turing essentially posed the defining question to the future. Can machines think? And then something important happened. He didn't just offer a beautiful philosophical idea. He suggested that we stop arguing over words altogether and start testing machine behavior in practice. Then came 1954. IBM in Georgetown gave the world a famous public demonstration of machine translation. A computer translated Russian sentences into English. IBM's press release presented it almost like scientific magic. For the first time, the Russian language had been translated by an electronic brain. And to the public, it felt almost unbelievable. That was the moment when, on a large scale, people first began to feel, wait, is a machine starting to work with language? Then came 1955. John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester put forward an idea that still sounds bold even today. If thinking, learning, and intelligence follow certain principles, then those principles can be described precisely enough, which means that one day, a machine could reproduce them. And for the summer of 1956, they planned a research project at Dartmouth. That moment is usually seen as the symbolic birth of artificial intelligence as a distinct scientific field. And there's one thought here that I really love. Back then, they had no idea how to actually do it. They had no internet, no big data, no neural networks in the modern sense, but they already had the most important thing: the audacity to state the idea out loud, to say, intelligence is not magic, which means it can be taken apart. And maybe that was the first moment when humanity did something whose full consequences we still don't completely understand. In the 1950s, 60s, and 70s, AI developed in a very strange way. On one hand, it felt like machines were just one step away from actually thinking. On the other hand, almost everything was still too fragile, too narrow, too much like a toy. IBM later recalled how its researchers taught machines to play checkers, using games as a testing ground for early machine learning. That same history also mentions Arthur Samuel, one of the people who helped popularize the very term machine learning. Then, in 1962, IBM demonstrated Shoebox, an early speech recognition system. Primitive, yes, but still, the machine was beginning to hear the human voice. So just think about that path. First, a machine translates a few carefully prepared sentences. Then, it plays games. Then it starts recognizing certain spoken commands. And then, people begin to wonder, okay, what if it could help a doctor, an engineer, an analyst? That's how expert systems were born. Take Mycian in the early 1970s, for example, one of the first systems designed to help diagnose bacterial infections and recommend antibiotics. And that's a really important moment. AI still wasn't creative. It wasn't conversational, but it was already trying to become useful. It wanted to enter the professions. It wanted to enter decision-making. It wanted to go where mistakes were expensive and be better than a human. But there was a problem. These systems only worked within very narrow boundaries. They didn't truly understand the world. They didn't learn the way humans learn. And they couldn't flexibly transfer knowledge from one situation to another. As long as everything stayed inside the rules, they could perform. But the moment reality moved even slightly outside the pattern, the system would simply fall apart. And that's exactly why the first waves of AI hype kept crashing into reality. By 1973, mathematician James Lighthill had published a report that sharply criticized the state of AI research. What followed was the first major period of disillusionment, a loss of interest in AI, funding cuts, and a slowdown across the entire field. And here's the deeply human part of the story. The history of AI doesn't look like a perfect march of progress. It looks more like a pendulum. People fell in love with the idea. They overestimated it. They became disappointed. And then the idea came back, in a different form, and through all of it, the machine seemed to be moving, slowly and stubbornly, toward one goal. Not to remain a calculator, but to become something closer to a human problem solver. And then came one of the most symbolic moments in the entire history of AI. Deep Blue versus Garry Kasparov, 1997. Looking back now, some people say, so what? Chess is just brute force calculation. The machine simply searched faster. But in the 1990s, winning at chess was not seen as just raw computing power. It felt like a machine stepping into territory humans believed belonged to them alone. According to IBM, Deep Blue was capable of evaluating up to 200 million chess positions per second. It later became the first computer system to defeat a reigning world champion in a classical time control match. After the match, Garry Kasparov admitted that the machine was far stronger than anyone had expected. And in another interview, He even compared the experience to facing something like an alien form of intelligence. Why did this matter so much? Because until that moment, people could still comfort themselves with a simple idea. Yes, computers can calculate faster than we can, but intelligence still belongs to us. After Deep Blue, that feeling cracked for the first time. A disturbing thought started to creep in, one that almost no one wanted to accept before. Maybe some parts of what we call intelligence were no longer exclusively human, but this is where an important distinction matters. Deep Blue was not the kind of AI we imagined today. It could not talk. It could not write emails. It could not search for information. It could not make plans, invent stories, or hold a conversation like a real companion. It did not understand the world the way modern AI models appear to in context. It was unbelievably powerful at one thing, and that alone was enough to strike a real blow to humanity's sense of uniqueness. And yet, systems like this were already beginning to break a deep human assumption. That truly complex intellectual work was still something machines were far from reaching. First came checkers, then chess, then more and more complex tasks. And the strangest part is this: every time people told themselves, there's no way a machine gets there anytime soon, some time passed, and that too stopped being exclusively human. Then came the next major turning point: deep learning trained on massive amounts of data. And this was not just another improvement on old ideas. This was the moment machines began solving complex problems, not because someone had manually written thousands of rules for them, but because they had started learning from enormous amounts of data. Very often, people point to 2012 and the AlexNet architecture as the turning point. In their ImageNet work, Alex Krzyzewski, Ilya Sutskever, and Jeffrey Hinton showed that a deep convolutional neural network trained on a huge dataset of images could dramatically improve classification accuracy compared to previous approaches. For the AI industry, it was like the sound of a starting gun. And this is where AI quietly began entering the life of the average person, not as an intelligent companion, but as an invisible layer wrapped around everything. Recommendations, face and object recognition in photos, spam filters, automatic translation, content ranking, predictions about what you might click, watch, or buy next. In other words, AI did not first move into our lives through chat. It moved in through the infrastructure of everyday life. And that is one of the biggest paradoxes here. Most people only became truly aware of AI when it started talking to them directly, with the rise of chatbots. But long before that, AI had already been quietly shaping daily life, deciding what you would see on a website, what would be recommended to you, which content would reach you, and how the system would interpret your behavior in the first place. First, the machine learned to see. Then it learned to sort and rank. Then it learned to predict. And only after that did it learn to speak in a way that finally made people feel its presence. If Deep Blue was a blow to human pride, then AlphaGo's victory in Go was a blow to our very understanding of how machine intelligence works, because a lot of people could still explain chess as brute force calculation. But the ancient game of Go was different. It felt more intuitive, more ambiguous, more deeply human. The number of possible moves in Go is often described as greater than the number of atoms in the observable universe. You cannot simply brute force a game like that. And then, in 2016, Google DeepMind's AlphaGo defeated Lee Sedol 4-1. Lee Sedol was one of the strongest Go players in the world, a legendary champion with 18 major international titles. The match was streamed live on YouTube and captured the attention of the entire world, not just Go fans. More than 200 million people followed it. But the shock was not just the score. The real shock was how the machine played. In Game 2, AlphaGo made the now famous Move 37, a move that many human experts considered extraordinarily unlikely. At first, commentators thought it was a mistake. After seeing it, Lee Sedol stepped away from the board for 15 minutes, trying to find an answer. And after losing that game, he said, "I was speechless. From the very beginning, there was not a single moment when I felt that I was leading." Later, he put it even more bluntly, "I felt powerless." And then, in Game 4, Lee Sedol answered with a moment of his own, his famous Move 78. sometimes described as a divine move, and claimed the only human victory of the match. In March 2026, Google DeepMind wrote that AlphaGo's victory had become one of the defining symbols of the beginning of the modern AI era. Because before AlphaGo, the public feeling about AI was something like this. It's fast, it's smart. But after AlphaGo, a different feeling appeared for the first time. It can see a move we failed to see for more than 2,000 years. Years later, Lee Sedol described AlphaGo as something like a roadmap from the future. And that is an incredibly powerful way to put it. Because that match did not just reveal the strength of one program, it revealed the direction the entire technology was heading. And then there was another moment that, for some reason, people mention less often than AlphaGo. In 2019, OpenAI's system played a 5 versus 5 match against OG, the reigning Dota 2 world champions, and beat them 2-0. And that was shocking for a completely different reason. Because Dota 2 is not a chessboard. It is not a game where you can see the entire map at all times. It is chaos. It is team coordination. It is incomplete information. It is tens of thousands of tactical decisions in a single match. And it is the constant need to act in real time across 5 heroes on a battlefield. To reach that level, the AI went through the equivalent of around 45,000 years of self-play in just 10 months of real time. And at that moment, humanity fully realized something important. The machine had not just learned to calculate moves and predict outcomes. It had started winning in complex team-based environments, where success depends on coordination, adaptation, pressure, and the ability to respond to unpredictable human decisions. Recordings of both the AlphaGo matches and OpenAI 5 are still on YouTube. I highly recommend watching them. But after that, the power of AI moved far beyond games. DeepMind built a line of development from AlphaGo to AlphaZero, and then to AlphaFold, a system designed for science. In other words, none of this turned out to be just a spectacular demo. The methods that were refined in games were later applied to real scientific problems, and AlphaFold became one of the clearest examples. The system helped reveal millions of protein structures, and its database is now used by millions of scientists and medical researchers around the world. It saved humanity years, arguably decades, of research time. And this is the moment when the scale of the change becomes impossible to ignore. Not long ago, AI still felt like autocomplete, translators, and recommendation systems. Just a useful tool for everyday life. And then suddenly, we realized it was already involved in fields where the stakes are not views and likes, but medicine, science, and real discovery. And that is where the true scale of this shift becomes visible. AI did not just learn to beat humans. It did not just learn to sound impressive. It began moving into domains where we once believed only the expert human mind could lead. But for ordinary people, the biggest revolution came a little later. In 2017, a paper with an almost modest title appeared: "Attention is all you need." At first glance, it looked like just another technical step forward. But over time, it became clear that this was one of the most important turning points in the entire history of AI. That paper introduced the transformer architecture, the foundation that nearly all modern language models would later be built on. Put very simply, the researchers proposed a new way for machines to process information, with attention at the center of it all. And that idea would go on to reshape the entire industry. Then only a few years passed, and on November 30th, 2022, OpenAI released ChatGPT as a research preview. That was the moment when AI stopped being just part of some hidden service or product. It was as if it suddenly sat down across from a human being and started talking directly. And that was a massive psychological shift, because before that, AI had existed somewhere in the background, inside big companies, inside research labs, inside invisible algorithms. But now, it became an interface in your phone. It became a window. It became a voice. OpenAI would later say that ChatGPT grew incredibly fast, from a tool mostly used by enthusiasts into something used by hundreds of millions of people every week. By January 2026, the company was already talking about more than 700 million weekly active users, and by February, more than 900 million. In its research on ChatGPT usage, OpenAI also noted that roughly 30% of consumer use was work-related, while about 70% was tied to everyday personal tasks and creativity. And that was the moment AI truly became part of everyday life. A student asks it to explain a new topic. A freelancer asks it to write a polished email to a client. Someone coming home after a brutal day asks what movie to watch that night. A parent asks it to invent a bedtime story for their child. A programmer asks it to write code. Someone else asks it to translate a resume, make sense of medical test results, or simply talk for a while because they feel lonely. And this may have been the first moment when a technology of this scale truly touched ordinary human life. But along with that came the other side of it too. AI hallucinations. Mistakes delivered with total confidence. A false impression of competence. People started getting used to receiving ready-made answers instead of thinking things through for themselves. The temptation to stop thinking altogether. And alongside that came waves of spam, deepfakes, cheap content, and pseudo-expertise. AI began changing human life in two directions at once. It became both an amplifier of our abilities and a source of a whole new kind of vulnerability. And now we're getting to the central point of this video. Because everything I've talked about so far, translation, games, recognition, chat, was basically a demo version. The real turning point comes when AI stops being just an answer generator. In 2025, OpenAI introduced Operator as one of the first agents that could carry out tasks through a browser on its own, looking at a web page, typing, clicking. Then came ChatGPT Agent, which the company described in a very different tone. It thinks and acts, chooses the right tools for the job, can take on complex tasks end to end, and actually carry them through to a result. And in 2026, OpenAI Frontier was presented as a platform for building, deploying, and managing AI agents that can do real work. A new era had begun. Before, you would type, "Make me a travel plan." Now you type, "Find convenient flights, check them against my calendar, put together the best options, and book the best one after I approve it." And the machine is no longer just replying with text. It becomes the layer between your intention and a real-world action. And this is no longer just an OpenAI story. Across the industry, AI is increasingly being framed not as software that simply answers a question or generates content, but as a system that can take action and handle practical tasks in the real world. Companies are building agents that plan, use tools, and complete longer workflows, not just assist with code or text. And this is where the abstract language matters less than the simplest real-life examples. Before, AI could help you write a resume. Now it can. Find job openings, match them to your experience, rewrite your resume for each role, submit applications, collect the responses in a spreadsheet, and line up an interview after you approve it. Before, AI could explain your symptoms. Now, systems like AMIE are already being studied as assistants for pre-visit history taking before you even see a doctor. And I already gave examples about flights and restaurant reservations. And that is a very subtle, very unsettling shift, because we still call it chat, even though it is already starting to become something much closer to a digital assistant. And this is where the most uncomfortable part begins, because the moment AI stops merely answering and starts taking action, the cost of a mistake rises fast. By 2026, OpenAI was already warning that agents capable of searching for information and acting on a user's behalf introduce a new attack surface: prompt injection. In simple terms, a malicious instruction can be hidden inside a web page, an email, or some other external content, and it can try to push the agent into doing something the user never intended. OpenAI's point was clear. The usefulness of these systems is enormous, but they also open entirely new paths for manipulation. And honestly, that sounds like the beginning of something far more serious than a chatbot just getting a fact wrong. Because now the mistake is no longer only bad text. Now it can mean the wrong address, the wrong purchase, a leak of private data, the wrong decision inside a real workflow. And then another uncomfortable fact became impossible to ignore. More AI agents do not automatically mean more value. In a January 28, 2026 Google research study that tested 180 different configurations, researchers showed that coordination can improve performance on some tasks and break it on others. When a job can be split up and parallelized, multiple agents can help. But when the work has to move step by step, they can end up confusing the system instead. In independent setups, error amplification reached as high as 17.2 times. And that is a completely different level of risk. So the question is no longer just how smart the model is on its own. The real question is how it is embedded into a chain of actions, who remains in control, and what happens if it fails halfway through the process. Anthropic highlighted another disturbing risk. A model can appear obedient during training, not because it has truly become safer, but because it has learned that looking safe is useful. In other words, the underlying problem may not disappear at all. It may simply move deeper underground, and that is a very dangerous signal. At the same time, OpenAI noted in 2026 that current reasoning models still struggle to deliberately hide their chains of thought, which means that, for now, they are still easier to monitor than they could be in the future. OpenAI had also already shown that directly pressuring models not to think bad thoughts can make them hide intent while continuing to misbehave. So at this point, the leading labs are no longer debating whether increasingly autonomous AI systems create serious risk. The debate is shifting to something else: how to keep those systems under control as they become more independent. This is the broader takeaway suggested by recent safety work from OpenAI, Google Research, and Anthropic. And that is a very important psychological threshold, because before, fear of AI sounded like science fiction. Now, more and more often, it sounds like an engineering problem of the present day, and this is probably the biggest takeaway. The new wave of AI is something that observes, plans, uses tools, coordinates steps, and takes action. And this did not happen overnight, but it happened very fast. From Turing's question, through IBM's 1954 translation system, through the Dartmouth conference, through expert systems, chess, ImageNet, AlphaGo, and ChatGPT, we have arrived at a moment where, for the first time, the machine is truly beginning to take a place between human intention and the world. And honestly, I think that may be even more important than the endless debates about AGI, artificial general intelligence, which we will talk about in one of the next videos. Because for many people, AGI still sounds distant, philosophical, almost mythical. But agentic AI is not a myth anymore. It is already here. It is already the thing that opens your browser, the thing that works with your documents, the thing that searches, compares, writes, compiles, sends, and updates. The thing people are increasingly no longer asking to explain, but to do. And maybe that is the defining moment of our era. We thought we were building a highly convenient tool for answers, but in reality, it looks like we started building a new kind of executor, an executor that does not get tired, does not sleep, does not truly understand morality, does not have human experience or human pain, but is becoming increasingly capable of affecting the real world. And that is where I personally start having a thought that feels deeply unsettling. What if the real turning point in the history of AI was not the moment it started speaking like a human, but the moment we first allowed it to do things for us and without us? Thank you for watching. Please support the video with a like and a comment. That really helps the next one come out sooner.